is Debodip Chowdhury. In this project, I built a machine learning system to detect fraudulent credit card transactions. The goal of the project was to demonstrate an end-to-end machine learning pipeline, including data pre-processing, handling class imbalance, model training, model explainability, and deployment using an interactive dashboard. The system uses the XGBoost machine learning algorithm for prediction SMART to address the class imbalance problem, SHAP for model explainability, and Streamlit to build a user-friendly dashboard where users can input transaction data and receive fraud predictions. In this presentation, I will briefly explain the problem the dataset used, the machine learning pipeline, and finally demonstrate the dashboard, including the entire application. So the next slide is about myself. So I am a London-based data science specialist. I am Microsoft certified data scientist, IBM certified professional data analysts, and I hold a master's degree from University of Bristol in data science. So basically, I work with different clients, including prestigious clients in the finance sector, healthcare sector, retail sector, e-commerce sector, and aviation or airlines sector to kind of solve their business problems using my data-driven methodologies. So the problem that I solved in this project was about credit card fraud challenges. Every day, millions of credit card transactions occur, and this lead to a significant number of potential issues. Uh, cre- Credit card is a significant challenge in modern financial systems. Millions of digital transactions occur every day, and financial institutions must detect suspicious activity quickly in order to prevent financial losses and protect customers. Traditional rule-based fraud detection systems often struggle to detect new or evolving fraud patterns because they rely on predefined conditions. Machine learning provides a powerful solution to this problem because it can learn complex patterns in transaction data and identify unusual behavior that may indicate fraud. The goal of this project is therefore to build a machine learning model that can accurately classify transactions as either legitimate or fraudulent based on historical and real world transaction data. Here we give an overview of the data set that we used. The data set that we use in this project is a well-known credit card fraud and real-world fraud credit card fraud detection data sets. It is through a research collaboration between a well-known payment service company known as Worldline and the machine learning group at University of Libre de Bruxelles in Belgium. This data set contains real credit card transactions made by European cardholders in September 2013. It includes approximately 284,807 transactions, out of which only So 492 are fraudulent. This means that fraudulent transactions represent about 0.172% of the dataset, making this dataset a highly imbalanced dataset. Because the dataset contains sensitive financial information, the original transaction attributes were transformed using principal component analysis. As a result, most of the features in the dataset are represented as anonymized components labeled V1 through V28. The only features that remain in their original form are time, which represents the seconds elapsed since the first transaction in the datasets, and amount, which represents the transaction value. The target variable is called class, where 0 represents a legitimate transaction and 1 represents a fraudulent transaction. Um, then we have the machine learning pipeline. So um, the machine learning pipeline for this project follows several key steps. First, the dataset is loaded and prepared for analysis. The data is then split into training and testing sets in order to evaluate the model's performance on unseen data. Because the dataset is extremely imbalanced with very few short cases, the synthetic minority oversampling technique is applied to the training data. This technique generates synthetic samples of the minority class to help the model learn patterns associated with fraudulent transactions. After balancing the dataset, the model is trained using XGBoost, which is a powerful gradient boosting algorithm widely used in data science and financial modeling due to its high performance and efficiency. Once the model is trained, its predictions are evaluated using metrics such as precision recall and F1 score. Finally, model explainability techniques are applied to understand which features contribute most to fraud detection. Then we go to model performance. So, how do we measure model performance? After training the model, its performance is evaluated using classification metrics. In fraud detection tasks, recall is particularly important because the goal is to correctly identify as many fraudulent transactions as possible. Missing a fraudulent transaction could result in financial loss, so it is important that the model captures the majority of fraud cases as majority as possible. To understand how the model makes predictions, feature importance analysis is performed using SHAP, which is a popular model explainability technique. SHAP helps identify which features have the strongest influence on the model's predictions. In this project, features such as V14, V4, V8, and V12 were found to be among the most important components for identifying fraudulent transactions. Now we go on to deploy our model uh, as this is an end-to-end project. So we go on to build the interactive dashboard. So this is the part of our application that we use over here so that to make the machine learning model interactive and accessible, we develop an application with a very strong visual dashboard that is built using Streamlit. So Streamlit is a Python framework that allows data scientists to quickly deploy machine learning models as web applications. The dashboard allows users to input transaction features such as time, amount, and the PCA components from V1 to V28, which are the features in this uh, project. Once the transaction details are entered, the model calculates the probability that the transaction is fraudulent. The dashboard also provides visual explanations showing which features contributed most strongly to the prediction. This makes the system easier to interpret and demonstrates how the model reaches its conclusions. So now we are going to share our app, app with you. So let me share the app. Application with the dashboard. So as you can see, this is the credit card fraud detection dashboard. This dashboard allows inputting credit card transaction features and predicting fraud probability. It also shows feature importances as well. So as you can see, the first step is the loading the data set, and the second step is about pre-processing, um, where we pre-process it and apply the synthetic magnetic oversampling technique to the dataset. Then the third step is about model training, where we train the model, build the model, and then evaluate the model on test data. As you can see, the precision, recall, F1 score, support, and all important metrics, including accuracy and weighted average, are here. Then we need to calculate the feature importance. We need to know which features are more important in determining the probability of transaction frauds. We need to know that. So these features here are mainly principal components. As you can see, the time and amount are important, and all other features are principal components. As this is a sensitive financial data set, we had to build principal components, and we couldn't reveal the sensitive attributes. Then as you can see, the model allows us to predict fraud for our new credit card values. So uh, so here, using this, we can change the values, as you can see, and the model will give us whether what is the class. So in this case, it is normal. The model is showing that the transaction is normal. So this is the GitHub repository containing my code, and let's have a quick notebook. This is my notebook. The app.py in GitHub. This is the notebook, and as you can see here, I have uh, loaded the data set, did data pre-processing, and then split the data sets, and then built a model. First, I built logistic regression. Then tried to move into XGBoost, where I did the precision recall curve as well, just to improve the XGBoost results. And we have improved the results. As you can see, our precision, our recall for fraudulent transaction is 0.88, and this is one of the most perfect results. And the precision is 0.54, and we increased the precision from 0.06 to, to 0.54 through the usage of synthetic minority oversampling technique and the precision recall curve which we used over here. So, uh, so this is the future importance values, and yeah, so that's what is about it. And as you can see, the entire code is in the GitHub repository, which is public, so anyone can view it. Uh, So this was our project. So in conclusion, these are some of the project outcomes that we have achieved. To summarize, basically, uh, we demonstrated a complete machine learning workflow for credit card fraud detection. The project included data pre-processing, handling imbalanced data using synthetic minority oversampling technique, training a predictive model using XGBoost, interpreting the model using sharp explainability technique, and deploying the model through an interactive Streamlit dashboard. So our system helps financial institutions and credit card companies detect suspicious transactions more effectively and significantly improve the overall security of digital payment systems. So thank you for watching this presentation.